Okay, so let's start cooking with this. Let's go and algebraically determine the equation of the inverse. Real quick, let's graph it. Let's see what we can get out of this graph. And oh, it's just gonna be awesome. Here we go. So f of x, of course, this becomes y. So y equals to x minus 2 squared minus 1. You know to interchange the x's and y's to give you the inverse. So this is now x equals to y minus 2 squared minus 1. Rearrange this so it's y equals 2, and we can use function notation. Bring the 1 over. X plus 1 on this side equals to y minus 2 all squared. Okay, square root. Don't forget the square root principle, making this plus or minus x plus 1 equals to y minus 2. Now, bring that 2 over, and you've got the inverse function being, check this out, plus or minus the square root of x plus 1 plus 2. There is your inverse function. Okay? Now, I know I did that a little quickly, but I'm pretty sure, I think you got the algebra down. All right, let's go. Now, it says graph both of these functions. Okay, well, we can do a lot of graphing here. First thing I'm going to do probably is I'm going to go with the original. I'm going to go with the original because there's so much information we can get off the original. This one becomes a little bit more complicated in a second, and I'll show you all about that in a minute. Okay, so first thing I would do is notice that this is in vertex form. So being that it's in vertex form, I know my vertex is 2 comma negative 1. Okay, so I'm going to go over to 2, 1, 2, negative 1. There's my point. Then I'm going to turn around. I'm going to say, okay, I wonder what the y-intercept is. And you remember the y-intercept happens when x equals to 0. So that means this is gone. You got minus 2 squared. Minus 2 squared is 4. 4 minus 1 is 3. So the y-intercept is actually 3. So I'm going to put that into the graph right there. Y-intercept is 3. Okay, so I've got a vertex, I've got a y-intercept. Beautiful. I wonder what the x-intercepts are. Okay, well, the x-intercepts happen, if you think about it, when y equals to 0. Oh, yippee skippy. Okay, so we got this function over here, and let me just clean it up real quick for you. We have this y equaling to 0, right? So that's 0 equals to x minus 2 squared minus 1. Bring the 1 over to the other side. You have 1 equals to x minus 2 squared, right? Okay, square root, you got plus or minus 1 equals to x minus 2, which means you've got 2 equations to deal with. You got x minus 2 equaling to positive 1. You got x minus 2 equaling to negative 1. Go from there and solve it. Bring the 2 over. This is x equals to 3. So guess what? We have a intercept right here at 3. And this one here, bring the 2 over, you got x equals to minus 1 plus 2 is 1, and lo and behold, there's the other intercept. Okay? Now, cool thing is you got 1, 2, 3 points. And you can actually have a 4th point, which is here, the intercept. And if you remember, you're going and you're mirroring this, a sister point. If you don't remember what a sister point was, it's this point right over here. It mirrors this one because of the axis of symmetry. Math 20-1, go watch those podcasts. So your graph comes down like this, comes around like this, and comes up like that. Oh, beautiful. Excellent. Okay, so there's our original. Now, we could turn around and we can end up going and using transformations and all that other stuff to figure out what this is. Well, if we use a transformation, it's pretty easy. Our x value's got to be negative 1, and our y value's got to be 2. There's our new vertex. Okay, x at negative 1 and y at 2. So it's got to be right here. Now, you're probably saying to yourself, well, how do I know that so quickly, and how am I sure that works? Well, check this out. Put down 2 comma negative 1. Flip it. This becomes negative 1 comma 2. That's what an inverse is all about. So can I do this with every question out there? Absolutely. Let's do it at this point. That point is 0, 3, and I'm just going to color it back in as green here. That's going to be 0, 3, so the other point is 3, 0. Okay, so our new point is going to be 3, 0, right there. How about these intercepts? These intercepts, if you think about it, this intercept is at 1, 0, so the next one is 0, 1. There's our next intercept right here. Okay, and this intercept over here, well, we've done this one already. That is 3, 0, so that's going to be 0, 3. Boom, up there. Oh, put it in blue. And all you got to do now is connect the blue dots. There we go. There's our inverse graph. Wow, cool. So let's play around with this chart over here and let's get a really good handle on how inverse functions work. Remember the domain on our original guy. The domain on our original guy is your typical parabola. X is an element of R. X can be anything it wants it to be. But the y here, if you think of the range, it starts down here at a minimum value of -1. So it's got to be greater than or equal to -1. The x-intercepts we figured out were at 1 and 3, right? The y-intercept we figured out was way over here at 3. Okay, remember, in inverses, everything is reversed. The domains are reversed with the range, so this now becomes a domain having to be, x has to be greater than -1. Yeah, well, no kidding. There's -1, and we have the entire graph going that way. -1 is the smallest value. And y can be, look, anything positive and anything negative. So guess what? Our y is an element of R. Wow, is that ever cool, right? How about our intercepts? You betcha. Your x-intercept is now 3, indicated by this beautiful thing right there. We figured it out earlier. And our y-intercepts are 1 and 3, figured out right here and right here. Oh my gotcha. That is out of this world. Now, the cool thing here is if you go down here, is the inverse of this a function? Let's do a vertical line test. You'll find out right away. But it cuts in 2 places. So in fact, no. Now, you could have done that off the original and say we could have done the horizontal line test off the original, and the horizontal line test off the original graph in green here, of course, intersects in 2 places. So that tells you no right away. Okay? But I got another question for you. Can I just go out and graph this and see my inverses? Well, actually, yes, you can. But am I going to go out and I'm going to graph this ugly monster of a question? Can't I use the graphing function of my calculator from the original, which was x minus 2 squared minus 1, just pop that into the calculator and let it work? Actually, yes, you can. Check this out. Go back into your calculator here, okay? I put in the original already. X minus 2 squared minus 1. Now, I could put down here the minus the square root of x plus 1 and blah, 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 blah. No, I'm not going to do that. What I'm going to do here is I'm going to do this. I'm actually going to draw the inverse. Now, if you look on your calculator, there's something really, really cool right here. It's the draw function. Interesting. Let's use it. Okay, how do we access it? Of course, it's in blue, so I have to hit the second button. Second, draw. And lo and behold, look, there it is way down here. Oh my goodness, draw the inverse. So I'm going to hit 8. But if I just hit 8, it's not going to know which one is there. I have to tell this through vars. Now, for some reason, it popped up right away. It shouldn't have. So let's try it again. Second, draw, 8. Yes, there it is. It will look like this on your calculator. How do I get the original function there? Well, yeah, you have to use vars. So alpha, F4, put in Y1. And we're going to have it draw it now. Now, how do I hit it? How do I get this to draw when it's on this screen? You can't hit graph. Graph ain't going to work. You have to hit, guess what? You have to hit enter. And check it out. There's the inverse. Draws it right for you. Isn't that pretty? The power of this calculator is amazing. And the things that you're learning on this calculator are super cool.